Hello students, welcome back to the session. So in this session we'll be dealing about different types of spectrums. So first let us understand what do you mean by spectrum. See, we have different sources of energies that gives out energy. So we have for example we have a fire, so which gives out heat energy. So similarly there are different sources which gives out light energy. So different kinds of energies are radiated from sources. So whenever we have these sources, that is the light which is emitting from these sources, so they will be having different wavelengths and they will be traveling in the space as electromagnetic waves. So that is, these radiations have different wavelengths and they travel through the space as electromagnetic waves. So in the electromagnetic spectrum, okay, so the visible spectrum is only a part of it. Okay, so now in this video session we'll be mainly trying to focus on the different types of visible spectrum. So now let us understand basically what do you mean by visible spectrum. So visible spectrum is nothing but the orderly arrangement of the colors that are present in the visible spectrum in some order. It may be in the order, increasing order of wavelength or decreasing order of the frequency. So this is what we call it as a visible spectrum. So we have different members in the electromagnetic spectrum. So the first member, if you go on the increasing order of the wavelength, so the first member in the series in the electromagnetic spectrum, we have the gamma rays, X-rays, then comes your UV, then visible, then IR, then micro and radio waves. So these are the different members of the electromagnetic spectrum. So in that electromagnetic spectrum, visible spectrum is only a very small part in it. So where the human eye can the human eye, is capable of receiving that wavelength and it will be visible for our naked eye. So this is what we call as a visible spectrum. So spectrum is generally defined, as I said, it is nothing but the orderly arrangement of the colors according to some wavelength, increasing order wavelength or decreasing order of the frequency. Why? Because wavelength and frequency are inversely proportional. So this is what we call as a visible spectrum. So here we can see in the diagram that we have different members in the electromagnetic waves, as electromagnetic spectrum, as I said. So in this diagram we have the decreasing order of the wavelength. So therefore the highest wavelength will be for the radio waves, and next comes the micro, infrared, visible, ultraviolet, X-ray, gamma rays. So it is in the decreasing order of the wavelength, and also we can see that whenever we have less in wavelength, so they will be having greater frequency. So since radio waves are the last member in the order of the wavelength, so therefore radio waves are having very less frequency. So therefore it is in the decreasing order of the frequency. So therefore, so this diagram will especially show you the members of the electromagnetic spectrum. So in this we can see that the visible spectrum, that is different colors are shown, that is violet, indigo, blue, green, yellow, orange and red. So this is what we call as a visible spectrum. So that means our eye is capable of seeing these range of wavelength. So the range of wavelength in the visible spectrum will be around from 400 nanometer to 800 nanometer roughly. So there is no perfect exact boundary between the blue color and the red color or the range of the wavelength. So depending upon the source, okay, so the wavelength will change slightly. Okay, so there is no exact boundary between the one color and the other color in the visible spectrum. So now let us see what are the different types of spectra that we can encounter. So visible spectrum is, as I said, is only a very small part of the electromagnetic spectrum. As I said, visible spectrum is only a very small part in the electromagnetic spectrum. So this visible spectrum can be classified on the basis of appearance, or it can be classified on the basis of wavelength, or it can also be classified on the basis of whether the source is an emitter or an absorber. Okay, so we have basically visible spectrum will be divided into different types, as I said. That is, one we have emission spectrum, or another we have the absorption spectrum. So depending upon whether the sample is an emitter or the sample is an absorber of radiation. So depending upon that, if it is an emitter of light, so we'll be getting the emission spectrum. If it is an absorber of light, so then we'll be getting the absorption spectrum. So this is based depending upon whether the sample is an emitter or the absorber of radiation. So we can classify the spectra as emission spectrum, or it can be classified as absorption spectrum. And next, based on the appearance, whether it is a continuous spectra or whether there is continuous emission of light, then we get continuous spectra. If we have a line appearance, then it will be called as a line spectra. If that line spreads, okay, so then that becomes the band spectrum. So this is the classification of spectra on the basis of appearance. Next type of will be based on the wavelength. So visible, UV, IR. Of course, these are the members of our electromagnetic spectrum also. So based on wavelength, so they will be classified into visible spectrum, UV spectrum, IR spectrum. So our intention is main to focus on the first two, that is emission spectrum, absorption spectrum. Under that we have whether it is continuous or line or band, or when do we get continuous spectra, when do we get line spectra, and when do we get band spectra. So that is the main intention in this video. So let us move on to that. So now, as I said, visible spectrum is mainly classified into two types. So one is your emission spectrum and the other is the absorption spectrum. So depending, as I said, depending upon whether the source is an emitter of light, if it is a self-luminous object, so then that will be called as an emission spectrum. So if it is an absorber of light, then that will be called as absorption spectrum. So moving on further, we shall focus on emission spectrum. So when do we get emission spectrum? So emission spectrum is obtained basically whenever we have any luminous source. Okay, the luminous source means any object which can give light by itself. So this is what we call it as emission spectrum. Luminous object or luminous source. So whenever the spectrum that is being obtained by a body which is luminous, then we call such a spectrum as emission spectrum. So this emission spectrum can further be classified into three types. So one is nothing but continuous emission spectrum, and another one is a line emission spectrum, and another is the band emission spectrum. So understand, students, so when do we get emission spectrum? Emission spectrum is obtained due to the emission of the light from any luminous source. As I said, luminous source means any body which can emit light by its own will be called as a luminous object or luminous source. So this results in the emission spectrum. So now this emission spectrum is further classified into three types, or three classes. One is the continuous emission spectrum, another is line emission spectrum, and another is the band emission spectrum. So now let us study in detail about the continuous emission spectrum, line emission spectrum, and the band emission spectrum. So firstly, let us focus on continuous emission spectrum. So when is this continuous emission spectrum is obtained, or what is the appearance of it? So if you come on the appearance, okay, so continuous emission spectra appears to be an unbroken band of colors which ranges from violet to red. Okay, so as I said, so there will be continuous emission of the light, so without any demarcation between one color and the another color, and the colors that appear in this continuous emission spectrum will be from violet to red. So there is nothing but the visible spectrum. Now, how will this spectrum appear? So one color will be just fading into another color without any boundary between or without any demarcation between the different colors. So this is the appearance of our continuous emission spectrum. So where we can see this continuous emission spectrum means, so this continuous emission spectrum can be seen whenever we have an incandescent or candle light. If you observe through any prism or diffraction grating, we can observe the continuous emission spectrum. I'll show in the diagram how the continuous emission spectrum looks like. So what are the sources? So whenever we have any bulk material, that is solid or liquid, when it is heated to very high temperatures, we can see this continuous emission spectrum. The examples for continuous emission spectrum are, one we have the tungsten filament, another we can use candle light. Okay, so these will be the sources for the continuous emission spectrum. In your childhood days, whenever we have power cut off, okay, so and if you light a candle and if you take the ruler, graduated ruler scale, and if you observe through that ruler scale the candle, we can see that there will be continuous colors of light that we can see, right? So we have experienced it, right? So similar to that, so the appearance of this continuous emission spectrum is shown in the diagram. So you can see that on to your right on the screen we have the blue, violet, blue, green, yellow, red. So as I said, it is a continuous appearance of colors without any boundary between one color and the another color. Okay, so here one color will be just fading into another color. Okay, so there is no perfect boundary between one color and the other color. So this is about the continuous emission spectrum. So the example for continuous emission spectrum is that is when you heat any tungsten filament electrically, or if you just heat any wire. Okay, so if you observe that wire or any solid material or any bulk material in then you get that continuous emission spectrum. So next is line emission spectrum. So this line emission spectrum is very important. So you need to understand this line emission spectrum, or you need to have this knowledge about line emission spectrum. Why? Because in my next video, so this will be again, we'll be discussing again and again. So when you study the vector atom model, or if you are going to study about the atomic models, okay, so there this line emission spectrum will knowledge will be very much applicable. Okay, so try to understand this line emission spectrum concept as much as possible. Okay, so what is line emission spectrum, or how does it appears like? So line emission spectrum is nothing but consisting of very large number or few number of bright lines against the dark background. So that is what we call it as a line emission spectrum. So the appearance of the line emission spectrum looks like that. That is, we have a few number of bright lines against the dark background. So this is the appearance of the continuous line emission spectrum, sorry. So each particular line will be corresponding to one particular wavelength. Okay, so we can see in the diagram, see we can see that there is a dark background, and in that we have some lines. Okay, so if you observe the mercury vapor lamp in your most probably 4th semester, will be having optics experiment in BSc. So there we can see that during when you observe that mercury vapor lamp, or we have this sodium vapor lamp. Okay, so with the help of any grating, you can see this type of spectrum. So this is what we call it as the line emission spectrum. So this line emission spectrum will be very much helpful for us in finding out the unknown elements which are present in the stars or any celestial objects. So how it will be helpful, or how is this line emission spectrum helps us in finding out the different unknown elements that are present in stars or celestial objects? Let us see that. So line emission spectrum, whenever we have atoms in the gaseous state or the vapor state at low pressure is excited. So then we get this line emission spectrum. You can see that sodium vapor lamp or mercury vapor lamp, whenever it is being excited electrically, okay, so we can see this type of spectrum. So what will be present in that mercury vapor lamp or sodium vapor lamp is we have some sodium gas or some mercury gas that is filled in that bulb. Okay, so if you excite it electrically, so the gas, there is atoms which are present in that, they excite from one energy level to another energy level, and they'll get the resulting they'll get the resulting spectrum. Okay, so this is the source of the line emission spectrum, that is the atoms or which are in the gaseous state or at the vapor state, if they are excited at low pressures, so then the resulting spectrum will be the line emission spectrum. And line emission spectrum is characteristics of the atoms emitting light. Hence, this line emission spectrum is also called as atomic spectra. So remember this line. So line spectrum or line emission spectrum is the characteristics of the atoms emitting light. So it is also called as atomic spectra. Means different atoms gives line emission spectrum in different regions of the wavelengths in the visible spectrum. So therefore, if you excite hydrogen, it gives out some line emission spectrum in some wavelength. And if you excite the carbon dioxide or mercury, okay, so neon, okay, so those different atoms will give you different wavelength. That is, the lines will appear in different regions. Okay, so not all atoms will be giving the same wavelength of lines. Okay, so in this visible spectrum, so different atoms will be giving out light in different regions. Okay, so hence we call this as atomic spectra. Why? Because it is a characteristics of the atom. So different atoms will give out you, or it will get you spectrum in different positions in the visible region. So therefore, different atoms will give out spectra in different wavelengths. So therefore, it will be the signature of the atom, we can call it as. Okay, so hence this is also called as atomic spectra. That is line emissions. Line spectra or line emission spectrum is also known as atomic spectra. So as I said, light from a gas or vapor at low pressure which is been excited electrically, that is sodium vapor lamp or mercury vapor lamp, so hence they will give out the line emission spectrum. So as I said, this is a signature of the atoms. Why? Because each element will produce its own characteristics line spectrum. So hence it is different from one atom and the other atom. So with the help of this study of this line emission spectrum, so we can identify the unknown elements that are present in different celestial objects or the stars. Okay. Example, as I said, sodium vapor lamp, mercury vapor lamp gives the line emission spectrum. So hope you have remembered this diagram. So this is the line emission spectrum. So next, moving on to the band emission spectrum. So how will this band emission spectrum looks? So band emission spectrum consists of a series of luminous bands, okay, against the dark background. Okay, so as we have seen that line emission spectrum, so similar to that itself, instead of a small line will be there is a spreading of that colored line. Suppose if we have a red color of light against the dark background itself, so that line will be spreaded into bands. Okay, so this is what we call it as band emission spectrum. So band emission spectrum consists of a series of luminous bands. Luminous means emission of light. Okay, so the brightest end will be called as the band head. Okay, if you move from that maximum where the the position where the intensity is maximum or the brightness is maximum, so it will be maximum at one end, and if you go on from one end to the other end, so the intensity goes on decreases. Okay, so the position or the point where the brightness or the intensity is maximum is called as the band head, and the point or the region where the intensity decreases or it will be lowering out. Okay, so that particular position is what we call it as the band tail. Okay, so this is about band emission spectrum. So and remember, this band emission spectrum will be also called as a molecular spectrum. Why? Because whenever we have the material in the molecular state, okay, so if you excite it, then definitely the resulting spectrum will be the band emission spectrum itself. Okay, and line emission spectrum is the signature of atoms, and band emission spectrum will be the signature of molecules. Hence this band emission spectrum will be also called as the molecular spectrum. So whenever we have the compounds of elements in the vapor state, okay, that is in the molecular state, it produces band emission spectrum. So example, we have the carbon dioxide, molecular nitrogen, aluminum oxide. So when they are excited, so you get this band spectrum. So next type of spectrum is your absorption spectrum. So when do we get an absorption spectrum? So absorption spectrum is produced whenever the light from any object is being there is light from any source giving continuous range of wavelength is passed through any absorbing material. If you have gone through the spectrum of KMnO4, that is, if you have an incandescent bulb, okay, so which is placed in front of a KMnO4 solution, if you observe the light that is coming out from the KMnO4 solution with the help of a prism or with the help of a grating, there we can see some wavelengths will be absent, or it will be not present there. That particular dark band or line will appear. So that is what we call it as an absorption spectrum. So absorption spectrum is produced when the light which is coming from the source, which is giving out continuous range of wavelengths, there is continuous range of colors, but still when it is passed through some absorbing material, some wavelengths will be absorbed by the material medium. Okay, then we get this absorption spectrum. For example, as I said, when you dissolve KMnO4 in water, okay, of certain concentration, and if you look at the spectrum which is coming, or look at the light which is coming out of the KMnO4 solution with the help of a spectrometer and the grating, so there we can see the absorption spectrum. So in this absorption spectrum, how it will look, we shall see. So this absorption spectrum is classified into three types. So one is continuous absorption spectrum, second one will be your line absorption spectrum, and the last will be your band absorption spectrum. So this is similar to that of the emission spectrum. Of course, there we have continuous emission spectrum, line emission spectrum, band emission spectrum. Similar to that, here in case of absorption spectrum, we have continuous absorption spectrum, line absorption spectrum, and band absorption spectrum. That's the difference. Okay, there is emission of light. Here you are observing the light which is being absorbed by the some material or some absorbing material. So that is absorption spectrum. So here also we have continuous absorption spectrum, line absorption spectrum, and band absorption spectrum. So now let us see one by one. So first we have the continuous absorption spectrum. So continuous absorption spectrum consists of continuous spectrum with a certain range of wavelength being cut off. Okay, so I'll repeat once again. So continuous spectrum consists of continuous spectrum with certain wavelength is cut off. For example, if we have a red color glass of light, and if you try to incident white color light, so that red color glass will absorb continuously all the wavelengths except red. So continuously it is absorbing certain range of wavelengths except red. Okay, so hence that particular red color glass appears red. Okay, so why? Because there is continuously a certain range of wavelength is been absorbed. So hence those colors. So white light consists of 7 colors: vibgaya, violet, indigo, blue, green, yellow, orange, red. So continuously it is absorbing the colors or the wavelengths from violet, indigo, blue, green, orange, and it is been left off. That is, only red color is left off. So therefore that particular red color glass appears red in case of white light. Why? Because continuously it is absorbing all the wavelengths except the red color. So continuous absorption spectrum consists of continuous spectrum with certain range of wavelengths. It may be one color or it may be many colors. So certain wavelengths will be absorbed or certain colors of light will be absorbed. So hence we get the continuous absorption spectrum. So continuous absorption spectrum is produced when light from a source which is emitting light is made to pass through solid or liquid at low temperatures. Then definitely you will get continuous absorption spectrum. So the wavelength that being absorbed will mainly depend on the temperature of the absorbing material. Example, as I said, when white light is passed through red glass, absorbs all the colors except red, hence red glass will appear red in case of white light, hence that gives the continuous absorption spectrum. Now second types of absorption spectrum is your line absorption spectrum. So the best example for line absorption spectrum is nothing but your solar spectrum. That is, if you observe the light which is coming from the sun with the help of a diffraction grating and an spectrometer, we can see beautiful black colored lines against the colored background, which is quite opposite to your line emission spectrum. In case of line emission spectrum, try to recall, students, that there was dark background but colored lines. Here in case of line absorption spectrum, okay, so you'll be having colored background, dark lines. That is the difference between line absorption spectrum and line emission spectrum. In case of line emission spectrum, you have the colored lines against the dark background, but in case of line absorption spectrum, you have dark lines against the colored background. That is the difference between emission spectrum and the absorption spectrum, right? So when do we get this line absorption spectrum? So this line absorption spectrum is obtained whenever we have the continuous spectrum is passed through the gas or vapor in atomic state. Remember that line spectrum in general is the signature of the atoms. Okay, so therefore line spectrum, it may be emission or absorption. It is called as atomic spectra in general. Atomic spectrum means you have to remember, or it should flash in your mind that it gives line spectra. It may be emission spectrum or it may be absorption spectrum. Atomic spectrum means it is line spectra. That's all, nothing else. Got it, students? Okay. Now this spectrum is obtained whenever the emerging light, if it consists of one or more dark lines across the colored background or continuous background, so that is a line absorption spectrum. So as I said, there is a solar spectrum is a very good example for the line absorption spectrum. So whenever light is made to pass through any gas, okay, such as sodium, we can see two closely spaced dark lines in the yellow region appears. So this is another example for line absorption spectrum. So line absorption spectrum appears like this. In this diagram, we can see that you can see there is a continuous colored background, and here and there we have the absorption lines, that is the dark lines are appearing. So this is the characteristics of some particular what we say atoms. Okay, so different atoms will give or it will absorb some wavelengths. Okay, again, so hence this line spectrum is also the characteristics of atoms. So hence line spectrum is also known as atomic spectra. Hope you have understood this. Next and the last type of absorption spectra is nothing but our band absorption spectrum. So when this band spectrum, how does it look like? So band absorption spectrum looks in a continuous spectra with some dark bands in between. So you can see this dark bands or band absorption spectrum in case of KMnO4 solution. That is, whenever we have certain KMnO4 crystals dissolved in water, if you observe the light which is coming out from this KMnO4 solution, okay, with the help of the spectrometer and the grating, we can see this band absorption spectra. So we have seen that line absorption spectrum, we have lines instead of that line, so that line will be spreaded into bands. Okay, so that is the appearance of the band absorption spectrum. So band absorption spectrum is a continuous spectrum. As I said, we have the colored background again with some bands, that is, instead of lines, that lines will be spreaded into bands, that is closely packed lines you see, so as a band. Okay, so it is produced whenever radiation from a source giving out continuous range of wavelength, that is incandescent bulb. When you pass this light which is coming from the incandescent bulb to any absorbing material which is in the molecular state, Okay, so you'll get this band absorption spectrum. The position of the dark bands will mainly depend on the absorbing material. So there is again, it is the characteristics of the molecule. So therefore this band or absorption spectrum or band absorption spectrum or band emission spectrum is nothing but signature of the molecule. So therefore it is also called as molecular spectrum. As I said, the example for band absorption spectrum is nothing but that is whenever we have potassium permanganate dissolved in water, so it gives out the band absorption spectrum. So hope you have understood. Finally we have the diagram for it. See here you can see continuous range of background, colored background. So and we have the dark line, dark bands instead of lines. We have some bands. Okay, so here and there depend again. See here we have some more colors in case of blue region. Why? Because it is a characteristic of that particular absorbing material. Okay, so this is your band absorption spectrum. Hope you have understood this spectrum concept. Okay, so I think we are at the end. So thank you very much for watching this video. If you like this video, please share to your friends or whoever they are interested to see. If you have any suggestions, please mention it in the comment box, or if you need any other more concepts, so please try to mention in my comment box. So thank you very much for all my subscribers for subscribing to my channel and helping us to make better videos. Okay, so your comments and suggestions are always entertained, good suggestions, and try to subscribe to our channel. And if you are interested in our channel, please mention in the comment box. If you have if you need any concepts to be done in my videos, so please try to mention in it. So whenever I find time, I'll try to make the videos, and definitely we'll update. Okay, so thank you very much for watching this video. Thank you. Meet you in my next video. So in my next video, so you'll be understanding what was necessary for this making of this particular this video, that is different types of spectrum. So why do we need the knowledge of different types of spectrum? So that will be discussed in my next video. You'll understand in my next video. So thank you very much, students, for your patience. Meet you in the next video. Thank you.